Let's understand spanning tree protocol in simple and straightforward way, no complications, just clear concepts. What is STP? So STP stands for Spanning Tree Protocol, which is a layer 2 protocol, and we define the IEEE 802.1d. STP works on layer 2, which is a data link layer of the OSI model. STP prevents a layer 2 loops by placing redundant ports in blocking state. So as you can see in this image, uh, there are three switches which are connected to each other, and here it is creating a loop. So by enabling the STP, you can see the port is blocked here. So because of that, we achieved a loop free logical topology. So basically STP क्या करता है, loop create होने नहीं देता है. No time to live in layer to frame is equal to infinite loop. ठीक है. STP's job creates a logical loop free topology. तो यहाँ पे physically हमें क्या दिख रहा है, three switches are connected to each other, but in logically this port is blocked, so the information is goes like here to here only, and then here to here. So this port is blocked. So because of that, there is no loop creation. So as you can see this image, this is physical topology which is looped. By enabling STP, it will block one port. ठीक है, यहाँ पे देख रहे हो आप, ये one port यहाँ पे block होने के बाद में, this is the logical topology which is loop free. Why STP is needed? So network engineer adds redundant path as a backup, but redundant paths can layer to loops, and it can lead to broadcast room, MAC table instability, and network congestions. So STP ensures only a one logical path exists between switches. So STP allows redundancy without loops, and by deciding which port will forward and which port will block. How STP works. So step 1 is root bridge election. So STP first elect one switch to be the root bridge. The central reference of point you can call as a boss of the network. The selection is based on bridge ID, which is priority plus MAC address. Okay, the switch with the lowest bridge ID will win and become the root bridge. Step 2, path cost calculation. STP calculates the lowest cost path from the switch to the root bridge. Third step, it assigns port roles. Root port, which is best path to the root. For example, this is switch. तो अगर ये रूट ब्रिज है हमारा, ठीक है, तो ये वाला जो पोर्ट है हमारा, ये और ये है हमारा रूट पोर्ट. डेजिग्नेटेड पोर्ट जो होता है बेस्ट फॉरवर्डिंग पोर्ट फॉर ईच नेटवर्क सेगमेंट, एंड द ब्लॉक पोर्ट which prevents loop by staying inactivate. PC1 sends a broadcast frame, तो ये स्विच 2 पे जाएगा, स्विच 2 ऑल अदर पोर्ट्स पे भेजेगा एक्सेप्ट PC1 एंड ब्लॉक पोर्ट. फिर S1 पे जाने के बाद S1 इसको ब्रॉडकास्ट करता है, देन इट विल गो टू S3 एक्सेप्ट स्विच 2. तो S3 पे रिसीव हुआ, S3 स्विच 2 पे भेजता है, बट इट इज़ अ ब्लॉक्ड पोर्ट, तो S2 इसको रिसीव नहीं करता, ड्रॉप कर देता है पैकेट को वहीं पे. STP रूल्स. रूट ब्रिज जो होता है वो सेंट्रल स्विच होता है, सिलेक्ट किया गया होता है बेस्ड ऑन लोवेस्ट ब्रिज आईडी. ब्रिज आईडी क्या होती है, प्रायोरिटी प्लस मैक एड्रेस, और जो सबसे लोवेस्ट ब्रिज आईडी है वो बनता है रूट ब्रिज. एंड द नेक्स्ट इज रूट पोर्ट. रूट पोर्ट क्या होता है? बेस्ट पाथ टुवर्ड्स रूट ब्रिज, वन पर स्विच. ठीक है, एक स्विच पे एक ही रूट पोर्ट होता है. डेजिग्नेटेड पोर्ट, बेस्ट पाथ सेगमेंट, and block port which does not forward traffic. Next is bridge ID. Bridge ID is basically the identity of the switch. It is used to elect the root bridge. Bridge ID is equal to bridge priority, which is default 32,768 plus MAC address. So ये जो priority होती है वो होता है 16 bits and MAC address is 48 bits. So the lowest bridge ID becomes the root bridge. So default bridge ID जो होती है वो 32,768 होती है. If there is a tie in priority, the switch with the lowest MAC address is selected. In this image, this is the lowest priority, 4096. So this switch will become root bridge. STP uses 5 states. Blocking state, which is the first state where it receives BPDUs, but it doesn't forward that. Okay. BPDU stands for Bridge Protocol Data Unit. It is a data message which exchange between switches to maintain the network topology. ठीक है? Then after that it comes to listening state where it builds MAC address table but it doesn't forward the traffic. So in this state basically BPDU जो है process होता है. After that the port goes to learning state. So learning state में it learns MAC address but it doesn't forward, and after that it goes to forwarding state. At this stage port fully operational mode में होता है and it forwards the frames. And the last one is disable where the admin can administratively shut down the port. STP timers. So hello timer default is 2 seconds and it sends BPDUs. Okay. Forward delay, which is a transitional delay, and it takes 15 seconds. The maximum age is BPDO aging time जो होता है वो होता है 20 seconds. So the total convergence time of STP is about 30 to 50 seconds. Port cost in STP. So STP chooses root port based on path cost based on link speed. So cost is inverse of bandwidth. The lower the cost, better path. We used to choose root port or non-root switches. Basically this is the link speed. इसके अकॉर्डिंग यहाँ पे जो है इसका कॉस्ट होता है. Now we will take a scenario. Okay, तो यहाँ पे क्या करना है, R3 को R1 पे कनेक्ट करना है. ठीक है, R3 से R1 पे जाना है. तो एक कौन सा वाला रूट लेगा, R4 से होके लाइक दिस, R3 to R4 to R1, या फिर R3 to R2 to R1. ठीक है, imagine the speed is 10 Mbps. ठीक है, तो यहाँ पे भी स्पीड 10 Mbps और यहाँ पे भी 10 Mbps. ठीक है, और यहाँ पे है 100 Mbps. ओके, सो नाउ कैलकुलेट द पाथ. अगर 10 Mbps की स्पीड है तो इसका कॉस्ट रहेगा 100. ठीक है, तो अभी 100 कॉस्ट इसका भी 100 होगा और यहाँ पे भी 100 होगा, बट 100 MBPS का कॉस्ट रहेगा 19। ठीक है, तो यहाँ पे कितना होगा 119 और यहाँ पे कितना होगा 200। तो R3 से R2 से होके वो R1 पे जाएगा, तो यहाँ पे होगा 119। अगर वो R4 से जाएगा तो इसका कॉस्ट होगा 200। ठीक है, तो यहाँ पे जो लीस्ट कॉस्ट है, ठीक है, जो लोवेस्ट कॉस्ट है वो है 119। तो इस तरह से जो है कैलकुलेशन होता है STP पे। टाइप्स ऑफ STPs, in this table you can see STP, which is a normal spanning tree protocol है 802.1d, which is slow in speed and it is a legacy network, old networks. And the new one is RSTP, rapid spanning tree protocol, which is 802.1w. It is fast, which is like 5 to 10 seconds, and modern switches में use होता है. And PVST plus per VLAN STP, which is in moderate in speed, and Cisco switches uses. And rapid PVSTP plus per VLAN rapid STP, which is fast and Cisco preferred. And MSTP, which is multiple STP group VLAN used for enterprises. So STP in real world networks. So redundancy is good but dangerous without STP. One wrong connection can bring down your entire LAN. For example, backup links between switches. Without STP, one broadcast can crash the network. With STP, you can get a loop-free topology, fast convergence with RSTP. Next is STP interview and exam questions. What is default STP priority? So priority is 32,768. Which protocol replaces STP for faster convergence? It will be the RSTP, Rapid Spanning Tree Protocol. And what is the role of the root port? Basically, it is the port which have the smallest path cost to the root bridge, and it will forward the data to the root bridge. Okay, root bridge. What command shows STP port states? So it will be show spanning tree. And the last question is, what is BPDU and what does it contain? So BPDU stands for Bridge Protocol Data Units, and it is a data message which exchange between switches to maintain the network. And that's your complete simplified STP explanation, clear, practical, and exactly how it works in real networks. And thanks for watching. See you in the next video.